this virtual seminar, Modular Construction, the Good, the Bad, and the Ugly. My name is Dr. Wendu, and I'm the Center Manager for the Center of Excellence in Smart Construction. Please note, we are recording this webinar and all lines are muted. If you need any help at any time, please send us a message via the Q&A chat box below. Today's event will last up to 60 minutes. We encourage you to ask questions throughout the event. Simply type them into the Q&A chat box in the lower center of the screen, and then be sure to click the send button. The Center of Excellence in Smart Construction is committed to advancing industry-led innovations in the built environment that will revolutionize the way we develop, manage, and operate smarter cities. We partner with like-minded organizations and government entities to lead the transformation of the built environment and development of next-generation professionals for the benefit of the economy. The Center is a global hub for disruptive thinking, a platform for collaborative research, and a model for solutions development and stakeholder engagement. The Center's industry-led research and development has a focus on enabling technologies around three main research themes: performance and productivity, sustainability, and well-being. The collaboration is intended to provide leadership in the future direction of the industry that will inform policy decision makers. We would like to acknowledge our four partners who have been integral to the development of the Center and their engagement with industry. And I'm pleased to say that representatives from our partners are on the panel at today's webinar. It's now my pleasure to introduce our esteemed industry and academic experts. Yasser is the Vice President of DoBox. He's been a professional engineer since 1984, a graduate of Aleppo University, and holds a master's degree in business administration from Liverpool University. With more than 36 years experience in specialized construction methodologies, off-site manufacturing, and design for manufacturing topped with modular construction. Yasser has participated in bringing many landmarks to the UAE to reality. As a co-founder of DoBox, the very first concrete modular construction facility in the MENA region, Yasser has been leading a revolutionary shift in the construction industry for the last decade, bringing change and innovation to traditional practices, and managed with his team to start a gate culture towards modular construction in the region. Yasser is also the CEO of B3G Engineering Services, established in 2019 to serve the construction industry with state-of-the-art disruptive technologies and innovative ideas to help the industry stakeholders to build smartly. Alex Mclaren is an architect, associate professor, and solo Decathlon lead at Harriet University. She's the Chartered Architect and Fellow of the RSA and HEA. She's Senior Director of Studies for Multi-Campus Architecture Engineering at undergraduate and postgraduate levels at Harriet University. She leads the Solar Decathlon Middle East project for the university, innovating in prefabricated, low-carbon timber construction, working with students and industry partners to develop a prototype solar-powered house to be part of World Expo 2020 in Dubai. Alex also sits on several industry committees, currently a panel member for CDBB Graduate Digital Capabilities Panel and CIPSI Knowledge Generation Panel. Her research interests are in built environment, cross-disciplinary collaboration, and training the future industry professionals. She believes that smart education and training for students, honing transdisciplinary communication and social skills, is essential to effectively implement the technical evolution of the construction industry and inspire future generations. Chris Tebb is the Regional Digital Lead, International Development, Southeast Asia, Middle East, and Africa for Mott MacDonald. He's a technology-passionate elder millennial who is a chartered member of the Institution of Civil Engineers and holds a single-figure golf handicap. Chris is currently overseeing the Digital Transformation Strategy and Implementation Program within the Global Delivery Services Unit, as well as leading McDonald's BIM consultancy and information advisory work in the Middle East. He has over 13 years experience in digital advisory, transportation, and built environment projects in the Middle East and the UK, working on projects for Highways England in the UK, as well as notable projects in the UAE, such as Route 2020, Mafraq Guifat Highway Upgrade, and Jumeirah Gulf Estates. Chris's notable achievements include leading the BIM consultancy team for clients that became the first federal government ministry to achieve an ISO 19650 kite mark and the first non-UK government entity to achieve a British Standards Institution kite mark accreditation for compliance with PAS 1192 parts 2 and 3, as well as leading McDonald to the 2016 Future Cities BIM Award. Manju Malige is Projects Director and Regional Solutions Lead for Jacobs, Bridges and Highways in the Middle East. Manju is an exceptional qualified engineer and design and construction manager with extensive experience in the Middle East and North Africa region. He has more than 28 years of experience managing the construction of civil structures and is responsible for the technical leadership of civil designs in the region. Manju has spent most of his career in civil engineering construction and has significant knowledge of working to regional standards. His experience extends to the management and design of a broad range of skills in bridges and civil structures, including major bridge structures across waterways, on creek crossings, having delivered the Garhoud Bridge across Dubai Creek, R999 Dubai Water Canal, R988 Creek Panorama Bridge, Dubai Skydive Runway, Palm Jebel Ali Bridge Main and Crescent Bridges, and non-traditional bridges across Sharjah Creek and Port Khalifa. I'll now hand over to Yasser, our moderator for this evening's webinar. Thank you.
Thank you, Dr. Nwundu. It is a pleasure being with such a remarkable setup like CSC and in the collaboration of Harriet University, which had been well known leading the merger between the academia and the industry in the region. I will go through a very short presentation before I hand over to Alex. Our subject is about modular construction. Modular construction falls under the category of off-site manufacturing. In fact, off-site manufacturing is well known in construction and has been used in different kinds of implementations, starting from casting bricks through prefabrication of building components like the door, windows, MEP modules in the near past, and reaching to precast and its remarkable application worldwide. Modular construction in the form of prefabricated components or in the form of PPVC, prefabricated, pre-finished volumetric construction, is rarely adapted in construction despite its merits of speed, improved quality, enhanced safety, and excellent sustainability performance. Such method of construction seems like the ideal alternative to conventional methods that are ripe for change, according to McKinsey, but we still see very shy adoption of it. We see very shy adoption of modular construction so far, and we need to know why and how we can improve. To do that, we gather together today, and please join me in this 1-hour webinar, accompanied with the academic industry and industry experts to discuss the challenges facing modular construction implementation in buildings and infrastructures. We start with the trigger of the discussion. For that, please welcome our esteemed presenter, Alex Mclaren, who will enlighten us about modular construction, the good, the bad, and the ugly. Alex, podium is yours.
Thank you so much, Essa. And yes, you've absolutely raised some key points that I hope I'll be able to build on in this short kickoff presentation. So just a moment while I share my screen. Okay, so let me check. Wonderful. So thank you very much for the invitation to join today. And in the next 10 minutes, I'm just going to rifle through what I hope will be a kickoff, a catalyst for a conversation with the wonderful panelists that I'm joined by today. I'm going to set the context for our discussion. Why is it that we're interested in modular construction? And then I'm going to go some way to begin to define modular, because as Yasser has just introduced to us, in fact, the idea of off-site manufacturer has been around for quite a long time. And what we're really talking about is an evolution rather than a revolution. We're going to have a quick look at a case study close to my heart, the Team Esteem Solar Decathlon Middle East House, which students who I am mentoring have been working through. But it gives us some really good key examples of the challenges which we face in the adoption of modular, which I hope we can apply to circumstances beyond just the house. And then I'm going to finish up with just some examples for discussion. So let's kick off with that context then. My argument, as many will be familiar with if you've worked with me before, is that our context is above and beyond everything else, the climate emergency. And in the context of the climate emergency, modular construction is a huge asset to us in reforming and remodeling the construction industry into something which is sustainable and which can support a net zero carbon future. Modular construction can give us really significant environmental benefits, and here's some simple examples of that. If we're manufacturing in a factory environment, if we're creating modules or panels or pods in a factory environment, then we waste a lot less. We don't need to overorder materials, we don't have the same level of potential damage to materials, and we have the opportunity to reuse the ends of runs, etc., in other panels that we're working on. On the building site itself, we use a lot less energy. We have fewer days on site. We have less plant. We have less of a construction site to service with all of our energy there, and of course water. And then the one overriding part, perhaps, of modular construction is the idea that we can be an awful lot more efficient and work on quality effectively, because no longer are we trying to construct in inclement weather conditions, but instead we have the security and the stability and the reliability of a factory setting in which to be creating our modules for a site. So these are really, really significant ways in which we can reduce the amount of energy that we use if we embrace modular construction. And that, of course, helps us in terms of improving the sustainability and responding to the climate emergency. So as Yasser said, modular construction has been around in some form for years, if we consider it as part of a legacy, which includes off-site manufacture all the way from, as you said, casting bricks. But we require a lot of investment, and this way of building requires our support. And when I say our support, I mean everyone hopefully listening to this webinar, across developers and clients and designers and contractors, because this needs a lot of investment. This quote from a study a couple of years ago, cited by the Centre for Digital Built Britain, highlights to us, although a lot of people say that they're working in modular construction at the moment, these methods of construction have a long way to go in terms of the vision we have of utilising robotics and moving beyond being simply indoor building sites. And what that really does need is investment and us to embrace these different methods of construction. Now, my argument, and you'll see from our case study, is that this needs to fundamentally change the way that we think about designing and constructing buildings, and that we need to embrace that as a whole industry in order to develop this modular construction. This is a slide from a recent report from the London Energy Transformation Initiative, and it's talking here about carbon impact. I'm still with my point of setting the climate emergency scene. But what this highlights in the larger pie diagrams that you see here is currently the amount of energy overall which is taken up by embodied energy and manufacture and maintenance versus the amount of energy of a building in use for, in this case, offices, residential or school as an example. But on the right-hand side here, what you see is where we're heading to if we hit our energy targets at the moment. And where that is that operational energy and the carbon impacts of that are massively reduced because we're managing to green our utilities supplies. And actually what we have here is a situation where the embodied energy, embodied carbon, and the impacts of maintenance and of construction on site in terms of the overall energy of a building are massive. And so for us to be able to embrace modular construction and decrease those will have a huge, huge impact on the future construction industry and the efficiency of that. So as an example here, looking at embodied energy, and again, thanks to the Letty report for this graphic, we see that we can actually affect all parts of this cycle of calculating embodied energy by embracing modular construction. We can reduce the amount of transport required to take different pieces to different manufacturing plants because we're working in one place. And because we're looking at repetition, we can decrease the wastage. We only have a more limited amount of transport to site because we're transporting modules rather than individual components. And that construction process is much reduced in time. We have an ability to potentially replace and maintain buildings much more efficiently because we have this repetition and this modularity. And then we can also think about taking buildings apart and effectively remodeling and reusing them and recycling the components. So modular construction to me is key to all aspects of addressing the climate emergency. A moment then to just define what modular is. And as soon as you begin to look at modular construction, you get yourself into a world of acronyms. A few of them are provided here. So of course, we're talking about intelligent design, and we're talking about building information modeling as a means of understanding digitally what it is that we're building prior to building on site. And I think that is core to an effective modular construction strategy. We are using modern methods of construction, MMC, and this is part, as Yasser said, of a history of off-site manufacture. A newer term, a newer acronym which you'll come across is Design for Manufacture and Assembly, DFMA. And I think this for me is a core one because it's where designers and consultants are beginning to understand that we need to change the way we design in order to effectively embrace modular construction. And then there's the definition itself of modular. When we say modular construction, do we mean panels? Do we mean a volumetric module, sorry? Do we mean pods, or are we talking about complete units? In the case of houses, complete rooms, or even complete houses. And all of these are part and parcel of what we're discussing in the webinar today. There is a wonderful report by McKinsey from a year or two ago, which discusses the potential for modular construction. And this is a wonderful, to me, definition of the different stages and efficiencies of modular construction. At the bottom left of the graph here, you have single units and single panels, moving at the top right here to fully serviced and finished houses. And what this highlights is increasing size and also increasing complexity of the different trades and different requirements for each type of module that we might be producing. I think when we speak of modular construction, many people assume that we're up at this end of this diagram, that we're talking about fully serviced pods coming to site, or perhaps even fully serviced and finished units. A lot of modular construction is still down at this end. And I think, and I'll be interested to hear from our panelists, that there are different efficiencies in working with either smaller scale pieces at perhaps a higher complexity, or indeed with larger panels, but at a lower complexity with additional services being added later. There's different take-up of this already around the planet, and there's an awful lot to learn from. Particularly if we look to Scandinavian countries, we find that they embrace a lot of modular construction in housing already. But again, from this report from McKinsey, we can see that if we look at Finland, Norway, and Sweden, where a lot of their off-site, their housing is already manufactured off-site, they appear around the center of this graph of construction readiness, if you like. We have another example being the UK, many other countries which potentially are ripe for disruption, ripe for this method of modular construction to be rolled out. And one of the big advantages, environmentally, yes, but also to all of us in terms of the efficiency of our society and of construction, is the amount of time that can be saved. If we are looking at volumetric modules on site, this report would argue that we can actually begin to deliver projects at 50% potentially of the time that we would in traditional construction. In the UK, this probably is still in its infancy. This is another recent report from the Centre for Digital Built Britain, looking at the different types of facilities which are available around the UK for off-site manufacture. And you see that they are very much divided into different categories in terms of materials. So some in steel, some in concrete, also scale, pods or modular buildings, and then panelized construction as well. And all of these different breakdowns have a significant impact on what is available to you as a designer or contractor on any one site that you are working for. So there is no one answer to navigate the landscape that I've just set out in front of you. It's very much based on the context that you have. A very short case study example then to illustrate exactly what I've just said. I'd like to show you a few drawings from Team Esteem. This is the Harriet Solar Decathlon team, led by a wonderful bunch of students who are exploring this massively exciting, innovative and complex project by working together across campuses through a pandemic to design an innovative solar powered house. Now, a core part, and here we are before the pandemic when we could all sit together and enjoy that. A core part of that house is an understanding of the structure and how it can be put together. And because this will be part of World Expo, we have a really, really tight timescale for actually assembling this house on site. It's going to be 2 weeks from a tabula rasa, a flat ground, up until the house being occupied. And this requires us, of course, to look at modular construction. Now, having investigated this and what is available, what the students have come up with is a hybrid of a panelized construction with some work on site and then elements of pod construction within that. And this is just to illustrate some of the technical difficulties which can come up when you begin to investigate the implications of working in modular construction. I should say a quick thank you to all of our sponsors here, and particularly I'm going to show you some work from the Construction Scotland Innovation Centre that we've been working with. But without all of these guys engaging up front at a very early stage in the design, we would really, really be struggling to get any kind of modular construction effectively engaged into this project. And that's one of the first lessons that I'd like to highlight here, is it really does involve all elements of those contributing to the design to be upfront engaged with the design stage in order to have everything ready to assemble on site. These are some example drawings of the panel construction that Team Esteem will be working with. And this is a timber panel construction, unusual for the UAE market and perhaps more suited and more suitable for the Scottish climate, where we're actually going to be growing the trees to make for. We have grown, but we're not growing them now. We have grown the trees that will be making these panels. But this gives you a bit of an insight into the hundreds of drawings which have to be put together prior to manufacture on site in a factory of these panels. And these drawings include the services runs, these drawings include the way that the structure is going to be fitted together. They also include additional structural connections for lifting pieces by cranes, because you have this kind of temporary moment where you need to be putting something together on site with a very different structural requirement. And all of this then needs to be understood in terms of how these are going to be put into different shipped containers, the order that they're going to be taken out of, and there's a huge logistics challenge around this. That's where we get our efficiencies, but it also means there's a lot more challenge for the designers, and it's a type of challenge that I would argue many designers are not prepared for, they're not ready for. What the students have worked together to do is to provide a logistics plan which allows us to mostly assemble panels with a few pods as well on site in this 2-week window. And that's the most efficient system that we have come up with. Now, it's only enabled because we have access to a factory like this. And this is the Construction Scotland Innovation Centre Innovation Factory in Hamilton, not that far from our Harriet University Edinburgh campus. And this is an example of the CLT, that is cross-laminated timber panels, which will be making the house. And they're about 100 mil thick, but after they come out like this, they're going to be laid down on this factory floor, lifted by these cranes and cut to exactly the right size. And then they can be fitted with the doors, the windows, and the insulation and the other elements of construction. And these are the facilities which are required to enable us to effectively make modular panelized buildings in order to then work with this in our project. So these are some of the lessons that we've learned. Having those facilities are absolutely crucial. And as you saw from the brief map showed earlier from the Centre for Digital Built Britain, there are not a lot of these facilities around in the UK at the moment. And I think that's a significant stumbling block for a number of countries. It's really, really important to front load the design, technical design. And I'd be really interested to hear from my other panelists here and their experiences of that, because in my experience, industry is not significantly prepared for that element of front loading, and perhaps clients are not significantly prepared for investing in that element of technical design prior to seeing anything actually appearing on site. It's important to understand how these are going to fit together, but making prototypes, which is how you need to understand that, is only effective if you do have a repetition in your design. And in terms of thinking about the good, the bad, and the ugly, I wonder if this is why some modular construction has a bad rep, because people see repetition and a lack of bespoke features as something which could be perceived to be ugly. I think we need to change our perception of that really, really significantly. And then finally, I will argue that design for manufacture and assembly is fundamentally different for designing for traditional construction. And the way that my student team have had to be working together across disciplines, thinking about integration, working with BIM and clash detection, it is fundamentally different to the way that I have been used to working in industry prior to this. I want to just wind up. I'm half looking at time and realizing I have run over, so apologies. With just some examples to set a wider context than that which I've just shown. And I could not but choose a wonderful example from Dubai, and Yasser, of course, will be very familiar with this from Dubox. But we have in Dubox in Dubai an example of really sophisticated modular construction, working in this case with concrete modules, and I'm sure Yasser can talk some more with us about the significant projects, mainly, I believe, domestic and in housing, which have been produced here. But this is another example of the scale of investment in facilities which is required to produce excellence, as you were, on this scale. There are other examples, and examples in the UK even, of non-domestic strategies, non-domestic applications, and this in case is a school. And I believe, and perhaps Chris would know more about this, that Mclaren have been really significantly involved in a rollout of new school facilities, working with modularized construction. In this case, it's an example of the porter cabin Yorkshire system. Many people, when thinking of modular construction, come to shipping containers and the possibility of shipping containers being used differently as residential construction, or indeed reused after use. This disturbs me somewhat because of the very, very constrained dimensions. And I think this is one of the things that gives, or has given, modular construction a bad name, or makes people think that they're ugly. These are not designed for human habitation, despite what the graphic on the left might have you believe. And so I would argue that we do need to embrace the modular, but we possibly don't need to embrace the idea of a 2.2 meter ceiling. There are so many examples of places where this can be really, really valuable, but I don't think we want to increase or to repeat the mistakes of the past, as it were. And these are a few photographs from Hong Kong. I was amused by the bamboo scaffolding, so I included it. But you see here the idea of repetition, of modularity. In this case, though, in a very, very old traditional style and really inefficient means of construction. This is surely what we can improve upon in terms of meeting the climate emergency and also improving the way that we live. There are some wonderful examples. This is a visit to the city of Freiburg in Germany with some of our master's students last year. And this is some pod construction and also some some panelized fun modular construction in incredibly highly efficient eco buildings. And then finally, an example from Dubai and a visit I had there a couple of years ago, looking over Jumeirah. And I think to finish here, I guess, what this tells me is that you can see in the right-hand image that we can have repetition and we can have really significantly beautiful urban spaces at the same time. And I think it is the responsibility of the construction industry to start to embrace modular construction and the overhaul of our perceptions of what it is to construct that entails. So my conclusions then: investment is key. Where that comes from and how we enable that is perhaps something we can now discuss. I would like optimization and enhancement and efficiency to be seen as more desirable than bespoke designs, because I think that has to be the way to go to meet the climate emergency. I'm excited to talk about the applications beyond buildings, and I raise that because, of course, as an architect, my preface here has been mainly buildings based, but Manju, I'm keen to hear about infrastructure as well. And I return to the idea that it isn't just an interest in efficiency or cost or even in digital transition which is driving this. This is a climate mandate. This is the way that the construction industry can actually become sustainable and can allow us to meet the climate emergency. So I will leave us there and hand over to hopefully some industry questions and also some views from my other panel members. Thank you very much, Jessa.
Thank you, Alex, for such interesting subject. And I'm glad that somebody is talking about modular construction as ugly, because this is in some corners it is ugly, although I'm one of those who are very well connected to modular construction. But yes, in some corners it is ugly. And I think I agree 100% with you that it is our responsibility as industry stakeholders and industry expertise, I would say, to handle such ugliness and eliminate it and make beautiful buildings out of modular construction. However, I have a question for you to trigger the panel, and I would ask saying, how do you see the modular construction in sustainability world? Do you see it the right answer for it? And here we are not addressing only the PPVC, we are addressing everything related to sustainability. Especially there is a good question here from anonymous attendees asking the question, is it sustainable and feasible to have CLT buildings in a climate like that of Dubai? Which he has a point.
This is a question back to me. I mean, yeah. Understanding embodied carbon involves understanding how the materials arrive at site, and Dubai doesn't have a lot of trees. So I would have to start by saying that importing timber to Dubai has its own questions all around it anyway. Our purpose for the Decathlon Middle East Expo is to showcase excellence from around the world, because it's part of World Expo. And that said, there is a lot of positive about timber construction. Of course, it is a way of encapsulating carbon rather than releasing carbon into the atmosphere. It is a renewable resource. There are many, many positives. So I think that is a question that is worth exploring, but only with a full acknowledgement and understanding of the additional embodied elements of carbon which sit within it. Of course, introducing a natural material into a climate and a context in which it is unused to, you need to think about humidity, you need to think about movement, you also need to think about potential pests or creatures who may begin to kind of timber. All of these are good questions, but I think that timber construction is a mandate across very, very much of the world in terms of reducing our reliance on cement, which is such a big problem for us in terms of carbon emissions.
Thank you, Alex. This could have answered the question. Yes, I would like to raise a question to Manju. Manju, we've met someday working on one of the projects using offsite manufacturing, and I know that you've been part of the team. You're one of the part of the team worked on metro. And the question would be, what was the driver behind the decision to go off-site manufacturing in the metro rather than going on-site?
Okay. Just before I come to this question, I would like to sort of touch upon sustainability, even in modular construction, especially Dubai. As you know, now they are very strict with the Dubai green guidelines, which replaces significant amount of cement with GGBS and slag, which are byproducts of industry. So there is a great emphasis on use of this sort of industry byproducts into concrete construction in the region. And to be honest, Jacobs have been a pioneer in this field. We have been using this since a Garud bridge. That was possibly the first bridge in the region where we have used about 60% slag in the concrete mix. Okay, and to be honest, it gives a very high dense, like a durable concrete. Just moving on to your question, Asser, the main driver on any of these infrastructure projects are schedule. For me, schedule drives the modular construction. You can't, have multiple work frames, okay, digging everything on site, using the conventional scaffolding. It doesn't work. Some of these metro projects would not have been built in the timelines that has been set in the contract. Modular construction, for me, it is the quality and uniformness and the speed of construction that drives. But unfortunately, the setup has been done, and that after completion of the project, that has been demobilized. So this is what, there is no permanent investment. Okay, unlike, before coming to this region, I had worked a lot in Southeast Asia, where you could go and order these, whatever we have been using here in the metro, standard sized from the factory, you can get. And you can tailor the molds to whatever the sizes you want. That was possible.
I agree.
And most of the construction in other part of the world, especially in the infrastructure field, it is all modular type.
Yeah, I agree with you 100%. I cannot agree more. Thank you very much. Chris, I have a couple of questions for you, but I will start with something I've seen from Omar saying, what are the roles of augmented reality and virtual reality technology in modular construction facilities? And actually, I noted, I put a note while Alex was giving the presentation, which falls under this as well. Can we reach to a day that we do construction with no mock-ups? Is it possible?
I suppose it depends on how you define the mock-up. I mean, we have examples, and using DFMA, which is our focus on this, because obviously we come from a design background. We've done construction without drawings. We've taken it straight from the model and it's gone to the manufacturer and the components, and this is for a railway bridge. And that's been constructed without drawings. So we're already making huge strides in that particular area. I think Alex touched on it in her presentation as well, is that this can be applied to so many sectors. Just to give some examples of the sectors that we've applied to, it's schools, water tanks, bridges. There was another question around whether this was the bastion of richer countries, and the answer to that is no. Refugee housing has been used from a DFMA perspective, and that's proven very successful because it provides the ability to replicate and standardize and reproduce very quickly and respond to displacement and migrations from both natural and man-made disasters. And it's not just permanent structures either, temporary structures for Olympic Games. Modular construction and DFMA have a huge part in that, particularly in the circular economy and them and dismantling them after major events when the capacity no longer becomes relevant. On the question of AR and VR, I think you just got to say is it something that is relevant to modular construction? Well, the answer is yes, but that's simply because it's very relevant to the processes that we go through now. You know, when we look at this, although 95% of the cost is in construction, 70% of the influence is in the design. So we've got to use techniques like AR, probably more VR in design. AR would be better suited in the life cycle, the operation and maintenance phase, possibly the construction phase. But we should be using these techniques available to us to make sure that what we're designing is not only going to suit the purpose for which it's being built, but also it can be built and it can be used. And those technologies will certainly help with that process.
I agree with you. And in terms of the modular construction for the temporary use, it can also be used for permanent for a certain time. And we've done in Dubox, we've done a couple of buildings in Dubai and Abu Dhabi as well, Ruwais, where they were designed to live there for a certain period of time. Then they were designed to be relocated. And here comes the question to you, Alex. And I put that note for myself when you were putting the presentation on. The question is, I know in the Decathlon, you built that, and you built it in a way that it's going to be dismantled. What if it was PPVC rather than being paneled modules, and rather than dismantling it, just dismantle the whole room with all its services and go back and rebuild it or reinstall it outside? What could be the time impact? What could be the saving in time in this?
So we are currently looking at the demounting of it, and because of the pandemic, of course, our ability to construct the prototype in Edinburgh has been pushed back until about now. We're about to finally. It's really exciting.
Yeah.
But no, this is one of the questions. It's where is the optimum efficiency? And I suppose what I wanted to raise in the presentation was that is really dependent on context. You know, our controlling features are probably the containers that will need to take it to Dubai. And it's going to be those volumes and the efficiency of using those volumes, which will control what we can do. There's a big question mark around the operational efficiency of, for example, airtightness of buildings and the ability to demount and remount buildings. And you know, one way to answer that is an awful lot of expanding foam and tape, and neither of those are particularly good answers either in terms of practicalities. I think that demountable, reusable, circular economy strategies for design are a given. I'm really excited and energized actually to find in my current conversations with professional institutions that they're thinking of changing professional codes of conduct to talk about borrowing materials in terms of the way that we use materials for buildings and for infrastructure, and therefore thinking about what happens to them at end of life. I think that's key. I think that's a real changing the way that we think about construction, full stop. So to answer Harry's question in the chat, yes, it's really important, and I don't know the answer yet.
All right. Manju, a question to you. I think you could help in answering it. Matthias asks, how can logistic challenges associated with modular construction be overcome? You've been through this, handling the huge elements of the metro. They were remarkably heavy and large.
Absolutely. You know, sort of this involves, you know, sort of actually, like Alex touched on this, it requires you know, sort of a robust planning from the beginning, including logistics and the technical solutions. Okay, if you miss any component of it, definitely you will have an issue. So for example, you know, like the background bridge, what you see on the back of my screen is, again, like, you know, we lifted about 200 ton, the closing unit. Again, it came in segments from Italy, and it was assembled on site and lifted in position. So there are ways to work around the logistics. And again, like, you know, the permitted, you know, vehicle weight, axle weight, we cannot exceed on the public roads, which is about 20 ton axle. So you will end up, that's where you size the segments in such a way that they fit into the standard transportation equipment and the lifting capacity which is available. Because otherwise, if you don't match that, again, the modular construction will not work. You know, procuring a special heavy lifting equipment or a transporter will cause problems. So again, having the plan at the beginning, okay, the way we vary the segment size, at the diaphragm, it is usually a shorter segment. Then as you go towards the midspan, it will be a little bit longer segment. We try to keep the weight around 40 to 60 tons. So this again, involved, a lot of planning is involved at the design stage.
Well, practically we couldn't, in our life, we couldn't, actually we start from 40 tons because we are using concrete, we are using precast as our raw material for the modules. So we started from 40 and we hit up 100 tons in some projects. But anyway, the infrastructure around us helped us in this. Considering other countries like Africa, for example, we would reconsider that 100 times before we decide on this.
Yeah, absolutely.
Whether we go modular as volumetric or we go panelized. Thank you very much. A question to you, Chris. Basil asks, what measures we are taking today to bring modular construction closer to productization and away from construction, perhaps using QR codes, trying to track the origin of the material is composed to control the majority of impact of environment. How can the DFMA and the digitalization of design help in this? Because it's not a matter of QFRD to recognize the panels and the location. It's not a matter of just putting the code. It's further. It's beyond that. How the design parametric designs tools can help.
It's a fascinating question. I could probably speak on this about 2 hours on its own. So
wow, we don't have that time. So
stay to see. What I did want to quickly do actually as well is I just wanted to pick up on the circular economy the chat, because one of the things, and actually some of the examples we've shown aren't great examples of this, but one of the things that the modular construction and DFMA does enable is it's not just the client, it's also about the social outcomes, and it's about improving local markets. So when you're using and reusing material, it stays within the space that the asset is being built, as opposed to being imported from other places. So modular construction is going to have a huge benefit, not just on the climate impact, but on the social impact as well. Talking around Basil's question, this is very much the future of construction, and things like BIM and DFMA. You probably would have heard the term Industry 4.0 as well banded around. These are all the start towards what the construction sector is going to look like in 10 or 15 years time. There's a lot more focus put on information, and currently for those of us that are involved in the design process or even the construction process, we use a lot of files, we consume a lot of files, and the industry thinking, or the future thinking, is very much aligned to how do we change that to object-based as opposed to file-based. So we start thinking about the actual virtual content of what we're building to enable it to be better built in the real world. And just to cite an example, there is an experiment going on, and I've got to credit I think it's Turner Townsend who are leading this, Dr. Marwan, who's also attached to Harriet Watt Centre of Excellence for Smart Construction. They've piloted using blockchain technology to be able to track the facade panels for one of the expo buildings. So basically what happens is that they can track from in a model, and it shows it as color panels, and each color means whether the panel has been designed, whether it's been approved by the authority, whether it's been constructed in the factory in Germany in this case, has it been shipped, has it arrived in Dubai, is it waiting for installation, has it then also, once it's been installed, has it also passed all of the testing required to make sure that that panel is in place and doing what it is to do. And they're working with Oracle to use blockchain technology to do that. So, it starts with BIM, about having that information in models. But there are technologies like blockchain out there that are also going to assist this. And, you know, modular construction is made for this because it is about making that product. So, you know, productization, it's an interesting one, because then you're trying to decide whether it's going to be standardized or bespoke. But, you know, certainly the engineering industry is making huge strides towards this, and it's very much part of future thinking.
Yeah, exactly, and I agree with you. It all starts with BIM, and BIM actually we are building a large data to the model that we are having, and at the end of the day, it's how to extract that data and how to handle it. This is what blockchain could help in this as well. Thank you very much. There are a couple of questions that actually the amount of questions are very good, and I see very good reactions on to the webinar, but the time is not going to help us to answer every single question. But I would answer a couple of them. I tried to answer some of them directly. One of the questions now is, what do you select? Would you choose traditional or modular construction? If you ask me, I would go modular all the way. When I drive my car, I see joints everywhere. So any building I look at, I imagine the joints in that building. So this is the way, yes, I go modular, but of course there are limitations. The limitations are related to function of the building. Sometimes they are related to the geometry of the elements that we are going to handle. There are limitations, and every project, it's not one full answer everywhere. It's not definitely one answer for this question. There are so many factors play a role in deciding this. I believe we are running out of time. We still have 3 minutes to discuss further, and I'm trying to select questions so that we can make this more fruitful. Well, a question from Bayan asking, it was at the beginning, asking, is it cost effective? I would choose Alex to answer this. Can you? Is modular construction cost effective? And otherwise, if it's not, how can the client benefit out of modular construction? Why to go modular construction if it's going to be expensive? Any balance?
I think I raised in the presentation that your investment is key, but the point is, once you have invested, oh my goodness, yes, you know, the cost efficiencies are huge. And a client to take advantage of that needs to have a really big picture view. They need to be looking to the future. And so we see a lot of investment in modular construction in some really large projects. And you know, the Dubai Metro perhaps is an excellent example, although Manju, you're telling us that it's now all been taken apart again. It's very, very construction industry, that story. So yes, I think the investments are huge, but we have a very, very fragmented industry, and we have a very few clients with the longevity of supply chains and engagements across the design and construction group of companies to want to invest to the scale that it is, which means that we start to push it towards governments and regulation to push us in this direction. That's ultimately, I think, where we have to start to look. But ultimately, yes, this is all about efficiency and optimization. And it is, when you look at it, it's horrific how inefficient and how unoptimized traditional construction is. I don't think it's really possible to argue against a modularized future of construction, if I'm honest.
Yeah.
As an architect, dare I say, who ought to be the one sensitive to aesthetics.
Yeah, and I believe this question has been answered by Manju before when I asked him why you chose modular, because he said time is the essence. When the investors put dollar number against the time and scale the return over investment, the early return over investment they are having, they will definitely realize this is saving that they have. Manju, a question to you again. Someone is asking, actually Muhammad Yushairi is asking, is design for modular construction is taken into account to earthquake design? How to ensure modular method can meet the requirements of low carbon emission and meet sustainability such as LEED, etc. If you can answer the first
yeah,
part.
Yeah, sure. I can.
Yeah.
Yeah, definitely. I could answer first point, and I would also try to answer the second point as well.
Yes,
Okay.
thank you very much. That'd be good. That'd be good.
Okay, the first point regarding earthquake design, definitely it can be incorporated into sort of a modular construction. It is not that complicated. It's the way you need to look at the detailing and other sort of information right at the design stage. And again, it is the proportion of the segments, the joints, placement. All these will play an important role. So that I would say, at the design stage, you could make that, okay, a decision. It's not going to be complicated. Regarding low carbon emission, again, I touched upon this. Okay, again, in concrete, you could use other sort of an industry byproduct, which is slag or GGBS, which is really very common. And again, it reduces a lot of carbon footprint. And again, these are all cast in a controlled industry environment. So you get a better quality and you have very good control on the quality. So again, you get that sort of a lot of advantage.
Thank you very much. We are really wrapping up time now, and I would like to thank every participant in this webinar. Thank you, our panelists. Thank you, Alex, for the interesting subject. And thank you for all the audiences. Really, I saw very, very vibrant interactions, and happy to feel that. I would like to wrap saying that modular construction could be the answer of every strange question about speed, about quality, about health and safety, but it cannot be the answer of every single project in the world. Definitely there are limitations, definitely there are difficulties, and the most barrier we have sometimes is two, actually, I would spot, which could be bad. It's the difficult engineering. It could be difficult. The other one, also in engineering, it's not flexible that much to play with every artistic view of the buildings, could be. However, in the Gulf, we might have changed this somehow, because all my life in precast, we used to design bespoke design shapes. And I used to use the term, we tailor make precast. We don't use precast in the parametric version that well known in the world. You can name it. You can have Atlantis. You can see Mercato. They are all very, very, very strange and odd shapes, but actually we could fulfill the architectural dreams. Thank you, everyone. And I would hand it over back to Dr. Windo to close this webinar. Thank you all for the participation.
Right, thank you, Yasser. And thank you to all our panelists for an interesting discussion, and our audience for your participation. We're well aware that there's quite a lot of questions that have been posted, and we'll attempt to answer them after this webinar. There will be a questionnaire that will be sent out about the unanswered questions in relation to this webinar. So I'd just like to advise you of our upcoming webinar, which is Green Hydrogen: What Viable Solutions Does It Offer for Net Zero Carbon? More details to follow, and that's actually, if you want to find out more details, the contact details sesdubai@hw.ac.uk are the contact details. So that concludes today's program. Have a wonderful day, evening, bye, and stay safe.